If a doctor tells you your temperature is normal, you breathe a sigh of relief. Everything is healthy, ordinary, and exactly as expected. But if a geometry problem tells you to draw a normal line to a curve, drawing an ordinary line will immediately get you a failing grade. We praise our friends for making rational decisions, meaning they acted logically, considered the facts, and kept their cool. Yet if an algebra test asks whether the square root of 2 is rational, trying to determine the number's emotional state won't help you find the answer. Stepping into the environment of mathematics acts as a vacuum. The moment you open a textbook, the standard dictionary definitions of everyday words are instantly overwritten. Attempting to solve a math problem by relying on your conversational vocabulary guarantees failure. The language looks identical, but the rules have completely changed. Surviving mathematics requires recognizing this vocabulary trap. To succeed, you have to learn how to translate language based entirely on context. Let's look at words we typically use to describe human attitudes or personality traits, specifically rational and independent. In everyday life, a rational person is reasonable, sane, and level-headed. This visual equation shows how mathematics redefines the word. Here, rational is a rigid structural requirement. It dictates that a number must be perfectly expressible in a fraction format, featuring one integer, a, over another integer, b, and b absolutely cannot equal 0. The word independent undergoes a similar transformation. An independent person is self-sufficient. They act alone, and sometimes they do things a little haphazardly. This probability tree illustrates the mathematical law of independent events. If you flip a coin twice, the 50-50 distribution of the second toss remains unchanged by the outcome of the first. One event cannot alter the probability of the other. In a math classroom, these words are never descriptions of character or vibes. They operate as absolute, uncompromising instructions for physical or mental calculations. This shift is even trickier with visual descriptors. In regular conversation, we use a word like similar to describe two objects that vaguely look alike to the human eye. The geometric definition of similar leaves no room for flexible assumptions. It demands exact precision, built entirely on scale factors. Vision is a trap. These two adjacent triangles appear to share the exact same shape and proportions, but to mathematically prove similarity, corresponding side length ratios must be perfectly equal. Measured against this grid, their scale ratios are actually disproportionate. They fail the similarity test. We see this exact same strictness with the word normal from our opening example. Normally, it just means typical. In this geometric diagram, a normal line represents a precise spatial relationship. It is a specific line drawn so that it meets another surface at a perfect, uncompromising 90-degree angle. Everyday visual language relies on flexible, good enough estimates, but geometric language requires unbreakable mathematical proof to function. Mathematics doesn't adopt everyday words to trick you. It borrows familiar concepts to achieve perfect, undeniable clarity. Navigating these double meanings depends on 3 specific habits: noticing the context, naming the mathematical meaning, and representing it with a strict rule. These definitions are the foundational laws that allow the entire mathematical system to operate with consistency. Take the word function. If you ask about a machine's function, you are asking about its purpose or its job. This mapping model demonstrates the unbreakable mathematical law of a function. Every single numerical input you drop into the system must route to exactly one output. The rule blocks any single input from producing 2 different answers. Internalizing this definition provides the rulebook for how mathematical reality works. True math literacy is recognizing context, demanding precise language, and seeing the hidden definitions governing the world around us.